Hello, everybody. This is 4.2 again. This is Integral Exponents continued. And I thought it's good to split it up into two parts. I did a kind of like simpler lesson last time, and here's some more complicated ideas. So for notes, I just want you to, review the exponent laws that I gave you last time. And the main one we want to remember is that a to the negative n is equal to 1 over a to the positive n, and that 1 over a to the negative n equals a to the positive n. The main thing for integral exponents, integral means like related to an integer. We're mostly talking about negative exponents. And another thing I want you to remember is that exponents apply only to the base. So remember, we have a power 3. This whole thing is a power. The big number is the base. The little number is the exponent. And so if we have, m n to the negative 2, this negative 2 only affects the n, not the m. So we'd end up only moving the answer would be, m over n squared. We don't move both of them. If it was in brackets, sure, if we had bracket m n to the negative 2, then that would affect both because now our base is in brackets. It's now m n. So 1 over m n squared. Oh, sorry, I shouldn't have in brackets. So just remember that it only applies to the base, and the base is the one immediately to the left. So let's simplify each expression. State the answer using positive exponents. We don't want any negative exponents. That's more solved. Here we have two polynomials. They're being multiplied. We need to multiply each part. So this 2 needs to multiply. We can combine like terms. The 2 can combine with the 3. This x can combine with the other x. And the y can combine with the other y. So they're being multiplied. 2 times 3 is 6. X times an x to the negative 1, we can add the exponents. So 1 plus negative 1 gives us x to the 0. And the y to the 2 plus the y to the 0. So 2 plus 0 is y squared. X to the 0 is just 1, so we can leave this as 6y squared in its simplest form. I guess we have A, B, C goes down. I might do A, D, B, E. You'll see. Here we go. We have negative 3xy to the 4, and this whole thing is squared, so we can distribute the 2 inside. So we have, it makes it a negative 3 squared. So negative 3 times negative 3 is going to give us a positive 9. 2 times, if we multiply that, there's a invisible little 1 there. We'll get x squared. And 2 times 4 gives us y to the 8. Let's do the next one. These are being multiplied, so we can multiply our like terms. We can do the negative 3 times the negative 4. That gives us a positive 12. We can multiply this m and this m. So same base. The exponents here are 2 and 4. They're being multiplied, so we can add them. 2 plus 4 is 6. And the last one, we have n to the 1, remember, plus negative 2. So 1 plus negative 2 is going to give us n to the negative 1. So 1 plus negative 2. And so we don't want in our simplification any negative exponents. So we can move this one to the bottom. We can go 12m to the 6 over n to the 1, or just leave it as n. Here we can distribute the negative 2 inside. So let's do that. Or, you could flip it to begin with if you would like. I might just distribute inside first. Actually, what do I want here? Maybe I will flip the whole thing. 1 over 4 x y, still to the negative 3 because we're just dealing with this 2 squared. Now we can distribute inside. 1 over 4 squared is 16. X to the 1 times 2 is going to give us x squared, and then we'll get a y to the negative 6. We can move this y to the negative 6 up here. So we will get y to the 6 over 16x squared. You could, either way, distribute from the beginning and give yourself, 4 to the negative 2, an x to the negative 2, and a y to the positive 6, and then move this part to the bottom. Would have got the same thing. You can do either way. C, I would start with combining here and then deal with our fraction. So let's start there. We have an m being multiplied by an m. We can, let me do m to the 3 and to the negative 2. We can add those exponents. So m to the 1 times m to the 5 is going to give us m to the 6. And this n to the 4 plus n to the 2 is going to give us n to the 6 as well. And now we can deal this way. So we have the same bases, they're being divided, which means we can, we can subtract their exponents. So 3 subtract 6 is going to leave us with m to the negative 3, and n negative 2 subtract 6 more is going to leave us with n to the negative 8. And we can reciprocate each of these bases, be 1 over m to the 3 and n to the 8. This one, I would like to distribute this inside first. So let's deal with our exponents first. So we leave our negative 4x, and we end up inside the brackets with 5 cubed. I guess I'll write it out. And x cubed. Let's do inside the bracket still. 5 cubed is going to give us 125x to the 3. And now we can distribute this inside. So the negative 4 times 125, I guess that'll give us 250 plus 250, negative 500. And this x times this x squared, it gives us x to the 4. Okay, so coming along, you get used to it as you go. It's good to just practice these, check your answers. This one here, let's see, there's a few ways I would do this. I might deal inside the brackets first. I think, I like to kind of stick to bedmass if I can. So I'll deal with this part. We have a 6 over 4. I can reduce that. We have an m's and we have our n's. So let's deal with that. Let me zoom in a little. Okay, so 6 over 4, we can reduce that to 3 over 2. And then we have m minus 2. Sorry, there we go. 1 minus 2 is going to leave us with m to the negative 1. And this n to the 3 minus 1 is going to leave us with an n to the positive 2. And this whole thing is squared. But I'm going to deal with this m first. That'll give us 3 over 2 m, that should be down on the bottom, n squared m to the 1. And now this whole thing is squared, so let's distribute inside. So we got 3 squared is going to give us 9, and we can multiply those exponents, n to the 4 over, this is going to square the 2. 2 squared is 4, and m to the 2. You could have, I suppose, if you want, distribute this inside from the beginning, distribute. I think I like to simplify first and then distribute, but really doesn't result in a different answer. This one, I want to start with our -2. And remember that it reciprocates the base. So this whole thing is in brackets, and it means we can flip this whole thing. We can end up with this part, the -2y is now going to be on top, and the 3x is now going to be on the bottom, and this is all now to the +2. So we just reciprocated the base. And now we can distribute this squared inside. So we get, I'll go down here. So -2 squared is going to give us a +4. And y squared is going to become y to the 4 over 3 squared, or 3 times 3 is 9, over x squared. Okay, so that's all of our simplifying. In these questions, they want us to evaluate. So they want us to end up with a standard form number. So give the result as a fraction where necessary. So they don't necessarily want a decimal. They'd like to see fraction as our final form. So here we have 5 to the -2. We can rewrite that as 1 over 5 to the +2, which is 1 over 25. And we'll just keep it as the decimal. As a fraction. We don't want a decimal. Here we have 7 to the power of 0. As you recall, anything to the power of 0 is just 1. Okay. Here we have a fraction. We have a negative exponent. That means we can reciprocate our base. So 6 over 7 becomes 7 over 6. And that whole thing is now to a +2, or positive square. Then we can distribute inside. We get 7 squared over 6 squared. And that equals 7 squared is 49 over 6 squared is 36. Next one, no negative exponents, but let's square just our base, so just the one in brackets. So we have a negative, and then -3 times -3 is going to give us a +9. So our final answer, though this, we can't forget this other negative, ends up being -9. Here we have a -3 to the -2. That means we're going to have -3 to the +2. And -3 squared gives us a +9. And here we have, I don't know, could be some tricky ones. You need to remember that our exponent laws don't really apply to addition. These don't have the same base, but we can write this as, 1 over 3 plus 1 over 4. And then, as you recall, to add fractions, we need a common denominator. So how do I make the same number on the bottom? The first number they both go into is 12. So we can times top and bottom by 3 on this side, top and bottom by 4 on this side. Get 4 over 12 plus 3 over 12. And our answer is 7 over 12. The rules not necessarily applying will be really interesting in H. I'll try to give you a good explanation of that to show how that works. Here, let's deal inside the brackets first. We got a -5. M to the power of 0, remember, is just 1. And n to the power of 0 is just 1. And that's squared. So now we got -5, 2, just adding inside the brackets, squared. And so we got a -5 times 2 squared. 2 times 2 is 4. And -5 times a +4 is going to give us a -20. And this next one, I want to point out something that I hope might be helpful, because we can just, flip both of these. We can show it as 5 to the 3 over 5 to the 1 plus 5 to the 2. But this could get us a bit mixed up from here if we don't remember that we need to kind of split this in a certain way. And so there's a better way, I think, for us to do this. And what I want you to remember about adding fractions is, say we had 1 over 3 plus 1 over 3. remember, we only add the tops. So this is like 1 plus 1 over 3, and that equals 2 over 3. So when we have something like this, we could... Okay, I got cut off right when I was getting excited. So, so what I want to show that we actually have here is you could think about this as 5 to the negative 1 over 5 to the negative 3 plus 5 to the negative 2 over 5 to the negative 3. So we kind of need to go in reverse, because if you do the next step of this one, if we do the next step of this, what you have is this. So if you can look, if this is this part right here and this is this part right here, this is like what our question is at. And so now we can apply our exponent laws and solve maybe more easily. So now we have a 5 to the negative 1 divided by 5 to the negative 3. So if we have negative 1 subtract negative 3, remember that's like adding a positive, we end up with 5 squared plus 5 to the negative 2 subtract negative 3. So negative 2 subtract negative 3 is going to give us a 5 to the positive 1. And then we have, I don't know why that looks like an F. Then we just have 25 plus 5, so 5 squared plus 5, and that equals 30. So this one I think could be easy to get pretty tripped up on, but try to think about our like addition, the way that we add fractions, and then use our exponent laws when we get to that step. This last one, I think I would solve inside the brackets first. Let's reciprocate our base. So 4 over 3, and that's going to be to a positive 2. Then we can, if you want, this is still to the 3. We could, distribute inside, but I'm going to do these first. So we end up with 4 squared, so 16 over 3 squared over 9, and that's to the power of 3. So you end up with 16 cubed over 9 cubed, and that equals, what is that? 16 to the power of 3, 4,096 over, I think, 9 times 9 times 9. What is it? Keeps doing that. 729. What it is, 729. Okay, there you go. Thank you so much. I have some extra practice that I'll give to you folks.